So C3, we have a hand grenade.
What?
Where we have a hand grenade
Everybody talk.
with that is flying through the air. It's 1.57 kilograms, traveling at 4.28 meters per second. So before it blows up, it has a certain amount of momentum, which appears to be 6.72 Newton seconds. Then it goes boom. When it goes boom, chunk 1 is going 55.7 meters per second, 27 degrees to the right. So we have one chunk that flies off this way, 27 degrees. So its mass was 0.578, and it is flying 55.7. So clearly its momentum is 32.2 Newton seconds. And again, since I clearly can see a triangle trying to form here, I say over here we're going to use cosine, over here we're going to use sine. So sine of 27 times the hypotenuse, or cosine of 27 times the hypotenuse.
Oh, I was doing it wrong because it was on radians.
Right.
I probably did it right then.
All the calculator's fault.
Yes.
So here we get 28.7
Oh, for the sign?
for the cosine. For the sine, you get 14.6. Then we have chunk 2, and chunk 2 is lying 42 degrees to the left. So degrees, and chunk 2 was 0.357, flying at 78.2. And you get 27.9. So again, over here we're going to use cosine, over here we're going to use sine. So I end up with 20.7 going that way. And we end up with 18.7 going that way. Then we want to figure out what happened to the third chunk. We need to know how big it is and where it's flying. Well,
Mass is the easy part.
the mass is the easy part. We started off with 1.57 kilograms, and we lost 0.357, and we lost 0.578. And that means we've got 0.635 kilograms missing, so that must be our third chunk. We won't need that so much later. Now what we're doing is we should be missing some momentum both sideways and up and down. So the missing momentum sideways, initially we were going 6.72. Afterwards, we are going 28.7, and we're going 20.7. So these are the two sideways components right here.
Add and subtract.
So this should equal that plus chunks 3 going to the side. Well, clearly these two numbers are bigger than that, so that means chunk 3 must be going that way. So if you get 6.72 minus 28.7 minus 20.7, you get negative 42.7. Then if we look at side to side, we had 18 going this way and we had 14 going that way. So since these are going in opposite directions from each other, we say, well, who is winning and by how much? So 18.7 minus 14.6 looks like 4.1, and the winner was going up, so that way. So now we're stuck with the third chunk must be 42.7 that way and 4.1 that way.
Is it because it has to equal to 0, like the vertical components?
Side to side, yeah, we didn't have anything going side to side initially, so that should still add up to 0 initially, or finally.
Or like the same, like they should equal
I'm
the
sorry,
same.
yes, yeah. It should add up to 0,
So
so
it
this
should go
should be
down.
going that way,
Yeah.
sorry. I'm on drugs. So yes, the total down should equal the total up, we were missing some down. So the third chunk is going that way. So then of course we just need to Pythagoras.
42.9.
I got 42.9. So that again is our P. And so since P equals mv, if we want to know the V, we need to divide by m again. So the mass we figured out earlier goes down there. Now if we just divide that by 0.65, then the velocity must have been 7.5 per second. And it was going backwards, but we have to figure out that angle. And again, to find the angle, we always want to use n minus 1. And we're going to do opposite over adjacent, so 4.1 over 22.7. Negative 5 degrees. So that should have been 5 degrees to the right factor
5 degrees to the right.
of straight factor.
I know it's this way.
Well, our original motion was this way, and so if you think of backwards, and then, well, compared to the original motion, 5 degrees.
Oh,
This is to the right of the original motion. I
It's
know.
very-
Okay, anyway, 5 degrees that
5
way.
degrees. From the
South
this
by
way
down east.
goes this way.
Yeah,
It's hard to say it, but I know what it is.
you see it in the drawing. 5 degrees this way compared to the original one. Great.